Hello, everyone. Welcome to the Honourable Speaker Series from Literary Education. In this event, we will be using both English and Burmese to communicate. So first of all, I'd like to talk about literary education. So our mission at Literary Education is to provide K-12 students in Myanmar with high quality and world-class education in science, technology, engineering, art, and mathematics, which is also known as STEAM. LTE also provides students in higher education and working professionals with ICT-related courses and training that are becoming important in the 21st century. If you have any questions throughout the event, please do not hesitate to ask. Ijamo, Hendra, and I will be in charge of moderating the event. So we are here to help you. Let's talk about today's event. So the name of the event, the topic of the event is Machine Learning for Kids. In this event, we will be talking about artificial intelligence and machine learning. We will also introduce a tool where even kids can use machine learning and build projects using programming languages like Scratch and Python. These topics will be shared by today's honorable guest speaker, Mr. Daly. So for now, Ms. Ijamu will introduce you about the speaker.
Hello, everyone. Good evening. It's so good to see you all showing up to our talk show. I'm Ichamo. Today, I will be a moderator along with Gojamua and Kohindra. First of all, let me introduce you to Mr. Dealing, who is the guest speaker of this evening talk show, proudly hosted by Literary Education. Mr. Dealing is working as a senior software developer at one of the thriving tech companies, IBM. Moreover, he worked at IBM's AI platform called Wesen, creating cloud services. He also publishes a book called Machine Learning for Kids and launches a website, machinelearningforkids.co.uk, which is being used by many students worldwide. Now, it's the time for inviting our honorable speaker. So I would like to extend a special welcome to our guest of honor, Mr. Daly, with a huge round of applause. Let's welcome him. Hello, Dale. Glad to see you.
You too. Thank you very much for having me.
First of all, I would like to say thank you for coming today. And honestly, we can't wait for your sharing. So let's get started and I will pass the floor to you.
Fantastic. Thank you. I will just start sharing my screen. Hopefully that's working. You can see that. Okay. Yes, thank you everyone for your time today. Thank you for having me. As you heard, my name is Dale. I'm a developer for IBM. And I'm going to be talking about some of the work that I've been doing to try and introduce AI and machine learning into schools. There's three things that I'd like to cover today. Firstly, I'm going to talk about why I think we should be doing this, why I think we should be introducing children to AI and machine learning. Secondly, I'm going to talk a bit about what I think in particular we should be teaching. And finally, I'll talk about how. I'll share some of the experiences I've had in how children can learn about this stuff, some of the projects that I've seen that have worked well, and what children have gotten out of them. So with that, let's start with the why. So why do I think we should be teaching young children, school-age students about AI and machine learning? Mainly because AI is everywhere. You know, we are all interacting with AI systems every day. Our lives are impacted by AI systems every day, and that is only going to increase. Not only that, AI is increasingly being used in more and more important parts of our lives, more and more critical parts of our lives, whether that's helping doctors and nurses to diagnose and treat some of our most serious illnesses, some of our medical needs, or whether it's driving the cars and the trucks that are on our roads, or whether it's making decisions about what jobs we can get or what bank loans we can get. AI is increasingly going to play a major role in some of these really important aspects of our lives. So this means we need the next generation of developers. We need the next generation of developers to be able to build these sorts of systems. And to do that, we need to start educating that next generation of developers so that they're going to grow up and be able to invent and apply these kinds of technologies. But it's not just about developers, because as machine learning systems increasingly become ubiquitous, we need that next generation to not only know how to build them, but how to use them. The last 10 years or so has seen an incredible democratization of machine learning technologies. Machine learning is no longer reserved to just being used by researchers and just being used by experts. And I believe that's going to continue. What this means is all students, not just the future coders, not just the future developers, will need to learn how to use these kinds of technologies. And the students who will grow up to be successful are going to be the ones who are best able to understand the potential, the ones who are best able to take advantage of data and machine learning. Think of the spreadsheet. In a lot of ways, spreadsheets democratized coding. There are office workers around the world who don't think of themselves as coders, who don't think of themselves as developers, but they're able to slice and dice data. They're able to get the insights they need from small amounts of data because they've learned how to drive a spreadsheet. Well, what is the spreadsheet of 5 years from now? What are the office workers of 5 years from now going to be able to do? And again, those office workers won't think of themselves as coders or developers, but they're going to be able to find hidden but critical insights in massive amounts of business data, because machine learning is going to become democratized to the point where it's something we can all use. So we need to start preparing and enabling those workers. And it's not just people who use it that we need to be preparing. We need to be teaching children about the implications of machine learning tech so that we can enable the next generation of leaders, the next generation of directors and managers, the people who are going to be making decisions about how and when we should apply this technology. We need the next generation of our business leaders to understand enough about the capabilities of this tech so that they can recognize opportunities for where it can be applied, and that they can understand enough about the risks to make sure it's done safely and appropriately. Sorry, speaking of risks, we desperately need a generation of legislators, of lawmakers, of policymakers who understand the implications of this tech that is already impacting our lives every day, this tech that's increasingly being used in more and more important and critical aspects of our lives, this tech that's going to become so readily available, so democratized that it's not just in the hands of experts anymore, but something that anyone can start using. And we can't just leave it to those lawmakers. We are long overdue for a serious debate about how and where we should be using AI. We need to discuss this as a society. We need to come to some decisions about what we think is and isn't appropriate. We need to agree on what we're happy with. And we can only have that debate when we have a population with enough of an understanding of the capabilities and the behaviors and the implications of the tech that they can engage in that debate. So I think we should be educating our children about machine learning to enable us to have that debate. So that's why I think we need to do it. But what do I think we should be teaching? It depends on who we're thinking about. You know, I did say that we do need a generation of developers and coders who can invent and apply machine learning tech, and that's only going to increase. So we do need to teach some children about how this stuff works. We do need to prepare the next generation who are going to be inventing the algorithms that make the stuff I work with today look simple and trivial. But in the same way that enabling the next generation of machine learning inventors isn't the only reason I think we should teach it in schools, it's also not the only thing we should be teaching. One of the objectives of education is helping children to understand how the world around them works. So even today, doing that surely has to include some understanding of what machine learning is and how it behaves. We need children to grow up understanding enough about machine learning so that they can understand the implications of how it's impacting their lives and their world. I'll give you an example. If you have enough of an understanding of the way that machine learning projects need training and test data to build a machine learning system, if you understand that, it helps you to understand the motivations of the companies who are doing it at scale. And that helps you to recognize where and why companies are collecting massive amounts of our data. Even if you have just a basic understanding of what drives machine learning projects, that gives you an insight, and it gives children an insight into the behaviors and the actions of big tech companies and the businesses who are using their technologies. Another example, bias in training data. that impacts the behavior of a machine learning system. Even if you have just a basic understanding of how that happens, you can start to understand and recognize risks that otherwise you might not spot. So this can help students to recognize where the risks are. It can also help them to recognize opportunities to make AI applications using machine learning tech that are more diverse, that are more applicable to all, that are more useful to all. And that's something we desperately need in my industry. Researchers and educators identify what we call 5 big ideas, 5 topics that we think it's essential that we help students to understand. And I'm only touching on a couple of these today. Firstly, machine learning, that students need to understand how computers can learn from data, from the training that they're given, from the examples that they're shown, how even the smartest and most advanced algorithms will be impacted by the quality of the training data that they get, the impact of biased, misrepresentative training data on what these systems do. The 5th one of these is impact. So students need to understand how the world around them is impacted by AI. They need to be able to engage in debates about how machine learning is overseen, how it's regulated. And these are debates that need to be based on a fundamental understanding of the technology. The point is, when I say we need to be teaching children about AI and machine learning, it's not about teaching algorithms for the sake of teaching algorithms. It's not about teaching tech for the sake of tech. It's about enabling students to understand the world that they're growing up in. So that's why I think we should do it. That's the kind of things I think we should cover. But what I want to spend most of my time today talking about is, how do we do this? So I'd like to offer some suggestions from the experiences I've had working with schools near me. I'm sure you will have heard of Scratch. Scratch has been a tremendous success at introducing coding to children by providing them with a sandbox that they can learn in through making. I found that Scratch is a fantastic environment for experimenting with AI technologies by extending that palette of blocks that you see on the left with additional blocks that represent different types of machine learning technology. So I've been able to add a variety of machine learning models to Scratch and make that available for children to start playing with. I've added additional blocks to the Scratch palette that do things like speech recognition or recognizing musical notes. So for example, ImageNet. ImageNet is a machine learning model that can recognize something that's in a photo. And that's what you're seeing here. It's a machine learning model that's been trained to recognize over 1,000 different types of thing. So that means that you can do a project like this, which is a really powerful use of machine learning. You know, here's a photo and it recognizes there's a baseball in that photo or a bear in that photo. But if you look at the code on the left, what the student had to do to make that work was really simple. You know, just building on what they already know from learning about Scratch already, but allowing them to use that knowledge to experiment and learn about machine learning. Another example, I've added a face detection model. That's a model that can find where in a picture a face is and what parts of a picture has a face. And that means students can make a fun project like this, where it's finding where her eyes and nose are and tracking that and moving an object around. So she made this like fun animated mask thing. And again, if you can see the amount of code that's involved, it's tiny. And it's a jumping off point for kids to start doing really fun things. One last example, there are machine learning models for question answering that can find an answer to a question in a passage of text. And that means students can make simple quiz games like this, where they make a Scratch project that can try to find an answer to any topic of their choice. The point of all of these is it's about putting really quite advanced machine learning tech in the hands of children, representing them as really simple blocks in a Scratch environment they're already familiar with. I found that that's a really fantastic way to introduce them to what this tech can do, to what is possible. Now, experimenting with existing machine learning models is a really good start, but what I found to be even more effective is allowing students to train their own machine learning models, letting them train the computer themselves, because then they can really start to see how this tech behaves. So as you heard in the intro, I made a website called Machine Learning for Kids, where students can train their own machine learning model for themselves. And it supports a variety of types of machine learning model, you know, as you can see here, text and images, numbers, sounds, but whatever type they choose, they are collecting their own training data to train the computer with. So, for example, in this project, they can train a computer to recognize commands. They create these two different buckets for each of the types of commands they want the computer to recognize. So here you're seeing a project where they trained a computer to recognize a command to turn on a fan or turn on a lamp. And then they entered in examples of how they might have given that command. They type in examples of how they would ask someone to turn on a fan or turn on a lamp. And what you can see here is they use this to train their own personal custom machine learning model. And some of these examples don't have to use the word fan or lamp. They can say something like, it's too hot in here, as a way of asking for a fan to be turned on. And then their own machine learning model gets represented as these blocks in Scratch, and then they can make a project like this. So this is something that they can ask it in, a new way of phrasing a command, and the machine learning model that they trained understands, recognizes what they mean, what they've asked for, and then does something, does a little animation. By making this, students start to get an insight into devices like Amazon's Alexa or Google Home or Apple Siri. By making it for themselves, they stop thinking of that kind of technology as a black box. They start to understand what goes into creating this technology, what goes into training it. And they start to understand the impact that this has on the decisions that the companies who make these devices have to make, such as, like I was sort of mentioning before, the fact that they need to collect lots and lots of examples of commands that people speak. Games are another great example of how to teach AI machine learning, because they can collect examples of the moves that they make in a game. So what you're seeing here is a Pac-Man game. By playing Pac-Man in Scratch, they get their Scratch project to store each of the moves that they make. And they use these moves to train a machine learning model that can then learn to play Pac-Man. So this is examples of where Pac-Man and the ghosts were when they pressed the up key or the down key or the left key or the right key. What they did is they collected examples of what was the state of the game when they made decisions to go left, right, up, or down. And they used all of those examples of their decisions in playing the game to train a computer to know how to play the game. So they train their own machine learning model, they take it into Scratch, and their model is represented as, again, a new set of blocks in Scratch. And they can use those blocks to put their machine learning model in charge of Pac-Man. So they take their hands off the keyboard and they watch Pac-Man, they watch the game play itself based on the training they've given it. And they see for themselves that with a few training examples, their Pac-Man is rubbish. It goes straight into the wall. When they add a few more training examples, it starts to get better. It can avoid that ghost for a little bit longer. As they add more and more training examples, their ghost gets better and better, and they can see it avoid the ghost for longer. And this starts to give them an appreciation of that need that companies have for collecting lots and lots of training examples to do a machine learning project. This one's a fun project. Students can learn about what we call sentiment analysis, that ability of machine learning technology to recognize the use of language. In this case, they're recognizing the use of language in a compliment as opposed to an insult. So they create these two buckets. In one bucket, they come up with examples of the nicest, kindest compliments they can think of. In the other, they come up with examples of the meanest, cruelest insults they can think of. And with these examples, they train a machine learning model that can recognize compliments and insults, and they use that to make a game in Scratch. What they'll often do is they'll make a character that can react to what you say to it. So here they've got this character. I mean, this is actually one I did because kids tend to draw their own because they're much more creative than I am. But you say something to it, you say something nice to it and it smiles, or you say something mean to it, which tends to be what particularly some of the children like to do, and they can make it cry. But the point is, by playing around with this stuff firsthand, having that hands-on experience, they start to understand the capabilities of sentiment analysis. And it means you can start having a discussion with them about the different ways that this tech is used. This sort of technology is widely used in fields like marketing and HR to help companies understand how we feel based on what they see us say, particularly in places like social media. So seeing what the tech is capable of allows you to have that discussion with children about how the tech is used and how they think it should be used. Chatbots are another great way of introducing an AI concept. Students can come up with what they think are the most likely questions that would be asked on any topic of their choice. and they can come up with a few different examples of how each of those questions could be asked. And then they use these examples to train a machine learning model to recognize what question is being asked about their topic. So the idea is here, these are questions about the moon. So students thought that someone might ask, how far away the moon is, how big it is, what temperature it is, what the moon is made of, and so on. They came up with a few examples of how someone might ask each of those questions. And then they trained a machine learning model using those examples, and then used that to make a chatbot. A chatbot that can answer questions about the moon. So you can ask it things like, what's the average temperature? And it gives you the answer. Now, the nice thing about this is I found that this kind of project engages students on more than just coding, because some students really enjoy designing and making their animated character that represents their topic. Some students will really focus on scripting those responses that their chatbot gives, giving it a personality, giving it some spirit and character. And students can do this on whatever topic they're currently studying. I've seen school students make chatbots about Romans, chatbot animals, chatbot presidents and prime ministers, and much, much more besides. Because what this means is this isn't just an AI project, because the focus of the project is whatever topic they've come up with, because they need to understand that topic well enough to think of what questions might be asked. They need to understand those questions well enough to think of a few different ways of asking them. They need to understand the topic well enough to prepare those scripted responses their chatbot gives. What I like about chatbots is it's a nice way for students to present what they've learned on a topic. In the same way that I see students being asked, a teacher might ask a student to write an essay to demonstrate what they've learned or make a presentation. Well, asking them to make a chatbot is just another way of getting them to demonstrate what they've learned. And I found that this kind of approach of integrating it into the curriculum, rather than just teaching AI for the sake of AI, is a really effective way of introducing it. Here's another example of what I mean by integrating it into an existing lesson plan. This is a project I did with a school where they were studying a media literacy course. So they were learning about how different news media outlets covered the same stories. So we reinforced that with them by doing a couple of lessons around AI and machine learning. What we wanted to see was, could the computer learn to recognize the kinds of patterns that they'd learnt about in class? So what you're seeing here are 4 buckets for 4 national newspapers in the UK. And they trained a computer to recognize the way that these newspapers write their headlines by collecting examples of headlines from each of these 4 national newspapers. And they used all of these examples to train a machine learning model that recognized the use of language from each newspaper. This machine learning model was able to recognize, for example, which newspapers tend to use capital letters in their headlines, which newspapers tend to have very short headlines, which newspapers have very emotional language in their headlines, which ones tend to be more matter of fact, which newspapers pick certain topics to put on their front page as opposed to others. And then they tested that machine learning model, again, going back to scratch by making a really simple game. This was something that they could give it a new headline that the computer had never seen before, and then it let that machine learning model predict which newspaper the headline probably came from. And seeing the answers that the machine learning project gave, seeing how many it got right, which ones it sometimes got wrong, all of that was really useful for them to reinforce what they'd been learning about news media. Recommendation engines are another really common example of how we use machine learning every day. Whether it's YouTube recommending or Netflix recommending what you might want to watch next, or Spotify recommending what you might want to listen to, or Amazon recommending what you might want to buy. This kind of machine learning technology affects our decisions, often without us really realizing. We use these patterns that machine learning models can learn to recognize to help us decide what to watch and what to listen to, what to read, what to buy. So students, it's helpful for students to sort of see what goes into that. Now, what we did here was just a really simple example. We made a recommendation engine that suggests places you might want to visit while you're on holiday. And you train this sort of vacation recommendation engine by giving it a description of your likes and interests. So what you're seeing here is people that like going to the museum might describe their likes and interests in this way. People who like to go to the fun fair might describe their interests in that way. And what they do is they train a machine learning model that you describe your interest to it, and it recommends where you might want to go on your vacation. But the idea is that doing this helps students to recognize what goes into making this kind of project, but crucially, how easily these kinds of machine learning models can be manipulated and influenced. So what they did is they used this to make, like I say, we made like a pretend phone app in Scratch that you would describe your interests and it would recommend where you might want to go on holiday. But we spent time intentionally influencing the model. So we gave it lots and lots of examples of, for example, going to the fun fair to see how that affected the recommendations the machine learning model gave. And that allowed students to think about the impact of how these systems can be biased for themselves in a first-hand way. It's not just about text, though. By collecting sets of pictures, you can train a machine learning model to recognize an image. So this project was just a really nice, simple game that I did with some really young classes. What we did is we trained a computer to recognize what a cow looks like and what a sheep looks like. And we made this sort of virtual sheepdog that can sort animals and put the animals in the right area of the farm. And this is something they can do with hardly any typing at all, because they just drag photos into the right place to train the machine learning model. And then they sort of put the machine learning model in charge and watch as their AI system can sort the photos for them. And there are lots of different patterns that a computer can learn to recognize, not just what an object in a picture is. In this project, students investigated whether a machine learning model could recognize what type of book a book is based on what the front cover looks like. So the idea is we want to see, can a computer judge a book by its cover? And the computer was picking up on examples like what colors were used, the style of the letters on the cover, what type of illustration it was it a photo or an illustration, and much, much more. But they found actually the computer would get really quite good at predicting what type of book it is, just for a new book that it hadn't seen before, just by showing it that picture of the cover. And it doesn't have to be in Scratch. All the examples I've shown you have been in Scratch, but making that as a phone app works really well as well. We've made games where you train a machine learning model on your use it on your phone, and then you can sort of hold the book up to your phone and it would recommend what type of book it is. And I've done that as a project in a library where we make it like a virtual librarian, so that the student has to put the book on the shelf that their machine learning models thinks it should go on. In this project, students collected examples of their writing, examples of postcodes, of zip codes, the kinds of things we write on a letter to sort mail. So they picked a few towns that were local to them, and they wrote the code that's used to represent that town on letters directly just onto the canvas, on the on-screen canvas. And we used this to train a machine learning model to recognize their writing. So what we did with this was we made a game that could essentially sort letters based on the postcode that we write onto the screen. I was doing this with really young kids, so we based it on a TV character, Postman Pat, that they were familiar with. So what they would do is they would write the postcode onto their on-screen envelope, and then when they clicked on the stamp, it would go to the right Postman Pat van for that town. Now, aside from being, this is a cool bit of tech, it's nice for them to learn about things like optical character recognition, what the tech is capable of. But what I really loved about this project is it opened up the students' eyes to how AI is all around us, because this was the use of AI that most of them weren't aware of. It's kind of what we think of as invisible AI, because large-scale sorting offices do automate the sorting of letters and parcels and packages using this kind of technology. So by making something simple like this for themselves, it was a really great way of getting them to start to think about how much of their society, how much of their daily lives are influenced by machine learning tech that they might not even get to see firsthand. And this is just some of what I've seen created over the last 5 years now. I started this site in 2017 with that goal of helping students to learn about AI and machine learning for themselves by making things for themselves with this kind of technology. But since then, you know, this has been used around the world in over 100 countries, and I see thousands of new projects being created every single day. You know, I just gave you a few examples, but students have been massively more creative than the sorts of projects that I think of. I particularly like seeing where students have invented their own projects rather than just following some instructions that I write. An example I saw, I think it was a year or two ago now, was some students had a classmate with a learning difficulty that meant they had trouble speaking clearly. And they found that, you know, they all had learned to understand them and their teacher had learned to understand them. But when their teacher was ill and they had a temporary teacher, a supply teacher, they would find that supply teacher often didn't understand their classmate. So they were interested in whether or not AI and machine learning could help. So they trained a machine learning model to recognize their classmate's speech so that machine learning model could act as a sort of AI interpreter for them. I love that, like as an idea of solving a real problem that they recognize for themselves, an idea that they came up with and tried it out, because they were able to have that technology in their hands in a form that made sense to them, that they were familiar with. Those are the kinds of projects that I love, not the ones that I've shown you that I thought of, but the ones that they dream up for themselves, because they've got AI tech in colorful blocks that they can experiment with by dragging and dropping. So, teaching children about machine learning, I've talked about why I think it's important, and crucially, not just for the ones who are really interested in code, not just for the ones that you typically think of as the techies who are going to grow up to become developers, but all children, because it's going to impact all of them. I've talked about the what, you know, what they need to learn, what the tech is, how it behaves, the kinds of factors that affect how it behaves, like the amount of training data, and crucially, those societal and ethical questions that this raises. And finally, I showed you a few examples of how I think we can do this. My obvious preference is through hands-on making and doing, letting kids see for themselves what's possible by showing them the way that this tech works and behaves. And with all of that, thank you so much for listening. And I think now we have time for questions.
Okay, sir. So Dale, one of our participants asks, will machines be better than humans?
That's a tough one. So I'll start by saying whether they're better than humans today, and avoid the future question for a second. We know how to train a computer to do a very specific thing today. Like, we can train a computer to recognize letters, and that machine is only good at recognizing letters, it can't recognize anything else. Or we know how to train a computer to recognize if some text is happy or sad, and that's all that model knows how to do. We sometimes describe this as narrow AI because we've taught it to do one thing really, really well, but it can't do anything else. That ability that humans have to know how to do lots of different things, and crucially, how to take what they've learned to do one thing and apply that in a totally different field to do a totally different job. That for computers to do that, that's we describe that goal as like a general AI, a strong AI, sometimes you hear it described, and we don't really know how to do that yet. We know how to train a computer to do one job, and when we want a computer to do a different job, we have to train it all over again. So today, computers are really good at specific things and can be better and faster at us. You know, they can do that job without needing to sleep or get tired or stop for lunch. But they lack that ability we have of taking what we've learned doing one job and applying it to a new job. Now, will we ever get to the position where computers can do that? I don't know. Certainly, I don't think it's going to happen anytime soon. Like, if it does happen, it's years and years and years away. But it's certainly an area that there are loads of people working to make happen. But today, we don't know how to do it.
Yeah, I totally agree with you. So, yeah, the next question is that, can AI be used in the filmmaking process? And if so, how can the process proceed with AI?
I mean, films already use a massive amount of sort of machine learning tech to help with visual effects and things like that. AI is fantastic as a tool for creative people to help them achieve things they might not otherwise be able to do. I think where creativity is a really super interesting area in terms of, can machines be creative? Like, can a computer come up with the idea for a film? Can a computer come up with, instead of being a tool that's being used by a creative human person, can the machine have that spark of creativity? There's a whole load of examples of where people are doing projects to see, can a computer, there's AI generated poetry, AI generated music, AI generated visual art, paintings, that learn from loads of examples of artworks that people have created and use that to generate new forms. I worked on a project several years ago now where we were interested in that idea of AI creativity. We used food and cooking as our example to study this field. We tried to train a computer that could learn how to invent a new meal that had never been cooked before by training it with examples of recipes from loads and loads and loads of existing meals. Now, is that the computer and the machine was inventing, creating, generating new recipes for new dishes that, as far as we know, hadn't been done before. Is that the computer being creative? It's debatable. I think yes, because we were following a similar creative process to what people did, but it was still learning from the input we had to give it and the approach that we told it to take. So, can a computer create a film? Again, I think it can help. I mean, where I see AI as being super powerful is where they enables people to do things they wouldn't be able to otherwise do. Machines, I rarely think of AI as replacing humans. It's about empowering humans to do more amazing things. So in that respect, absolutely, AI is driving the film industry. Will it ever just do it all itself? Again, I don't think so, but certainly not anytime soon.
Yeah.
Okay, thank you.
Okay, so yeah, the final question is, I heard you said it in your answer, but I will ask it. So, will AI completely replace human in the future?
There's that fear is often raised. I don't think so. I think an example I've used before is, I remember when I was at school, my dad was fairly negative about the fact that I was allowed a calculator in maths lessons, because in his day he used slide rules and manual tools and mental arithmetic and pen and paper arithmetic, and he was sort of like, well, you can't understand if you're just typing the sums in and you get the answer. It's what are you learning? And the argument I never sort of used at the time, because I was just a child, but in hindsight I wish I'd said, was by doing that mechanical part of it, like the sums, it freed me up to do more complicated algebra and sums in my lessons than he would have ever done in his lessons. The machine was enabling me to sort of by doing that bit for me, it was allowing me to go up a rung of the ladder and do the more complicated maths. I see AI doing a similar thing. It's by doing the sorts of things that today we have to do, it enables us to go up another rung of the ladder, to do the things that are even more complicated and even more powerful than we'd be able to do without it. So I see AI as an enabler. I see AI as giving us a leg up, as helping us go up one step. In the same way that the calculator did when I was a kid, AI is helping me do more powerful things today. And so it's replacing some of the tasks that we might do, but I don't see it as replacing us, because by replacing those tasks that we have to do today, it means we can do more amazing tasks tomorrow. Now, that I'm naturally an optimist because I've chosen to spend my life in technology. So naturally, I'm going to see it as technology as a positive thing. I know that there are lots of people in industry, in the field, who have a more negative view, who do sort of see that AI doing jobs that are currently being done by people as a threat and as a risk. But personally, I don't share that.
Yes. Thank you for sharing your experience and work today. So I've been searching about roadmap to become an AI engineer. I found that most we have to complete an undergraduate course majoring in maths or computer science related fields, and plus master degree in AI or within technical competencies like machine learning, deep learning, statistical knowledge and so on and so forth. And then some require business skills. So my question is, what I have taught makes sense to you, or any advice or any roadmap for those who are studying to stand as an AI engineer? Thanks, Mr. Day.
Cool. AI and machine learning as a field is so huge now. There are so many different avenues you can go down. We absolutely need, like you say, someone who understands the statistics, the maths, because under the covers, you know, we anthropomorphize, we describe AI in human terms to try and as like a metaphor. But in reality, we can't get away from the fact that it's just a massive amount of statistics under the covers. So we absolutely need people to learn the deep maths to help drive the tech forward. But equally, and I use the spreadsheet as my example, you know, there are people using machine learning today doing amazing, powerful things who don't. And actually, you know, like I'm okay with maths, but I'm not amazing. Like it was never my strong suit. So you can be successful, you can make a difference, you can have an impact in this field in other ways. You know, I've worked with, particularly as this tech is getting increasingly affecting everyone's lives in everyone's hands, I've worked with designers who are not at all technical, but who understand how to make this useful to people, who understand that really important field of human computer interaction and how we enable humans to interact with AI, but they're not at all techie or developer. As I said, I kind of think that ethics is a really important field. And some of the people who are doing amazing work in that space are maybe not deep mathematicians. So I guess my advice to finally get around to my answer is pick the area that fascinates you, pick the area that inspires you, and pursue it. And if it is the maths, fantastic, we need that. But if it isn't, don't let that put you off, because there's so many ways you can have an impact and make a difference without necessarily being a deep mathematician. I find that actually, like as we assemble teams to work on machine learning projects, the skill at the moment that's the highest in demand, that's the hardest to find skill in, are people who can help slice and dice data, because the smartest algorithms in the world are useless without a massive amount of well-prepared, cleaned training data. People who are able to do that ops task, that who can script, who can slice and dice huge quantities of data, like people who can do that are so highly valued on any sort of project that I've worked on. So and they're not at all statistics people. So yeah, I would say find the area that inspires you, find what you can be passionate about, and pursue it.
Thank you, Mr. Day. This made a lot of sense to me. Thank you very much.
Okay, thank you for the asking questions and the answer. Yeah, so there are many areas that you can focus on depending on your interest and your motivation is. Yeah, so okay, so we will take another questions.
Oh, hi. Sorry, can I ask some question?
Yeah, sure.
Yes. Thank you for your time, and it was a great speech. So what I would like to know is about the bias of the model. So as I understand, we have a scratch. So at the scratch, we train our own models, right? So, and the student will have to collect their own data. In that case, will the model be biased on the data sets? What are your views on this? Yes, thank you.
So I'm fascinated by bias as a topic, and my favorite lessons are where that sort of has happened accidentally, as you sort of imply. Actually, I'll share my screen again quickly. I'll show you a project I loved. So we were doing rock, paper, scissors. So the idea is students would hold their hand up to the camera, take a picture of their hand in either a rock or a paper or scissors shape, and then train the computer to play rock, paper, scissors against them. And there was one time I did this where the student did a decent job of collecting examples of their hand making a rock shape. I'm having to use photos because cartoons, because I can't show you photos of children in classes. They did a good job of the scissors one. They held their hand up making a scissors shape, took loads of photos, fine. But when they were doing their paper photos, one of their classmates had come and stood next to them and was just chatting. And in all of the photos of paper, it was their hand and their friend stood next to them. And what they hadn't realized was that they'd biased their machine learning model. So what their machine learning model had learned was a hand means rock or scissors, depending on the shape, and a hand and a person means paper. And they didn't realize that until, as they were getting further into their Scratch project, we spotted it accidentally. It was when their teacher or me stood next to them to see how they were getting on. Their machine learning model always said paper, and then we would like step away and their machine learning model would say rock or scissors, and we'd step back in and they would say paper. And it took us a little while to work out why was it doing this. And we went back and looked through their training examples, and then we saw that all of the examples in the paper one had their friend in it. And that was a fantastic chance to talk to them about how they had biased, how they'd impacted their machine learning model in that way, totally by accident, but it allowed us to have that discussion. And I sort of mentioned this one where we were doing the holiday one. What I sort of didn't cover is exactly how we did it. So it was that idea of, we intentionally asked the students to put loads and loads and loads of examples in the theme park and hardly any examples in the fun fair. Because by doing that, whenever you ask that holiday app, oh, I want to do something exciting, it would say theme park. I want to do something fun, theme park. It was really hard to get it to recommend the fun fair. And so you can do that. You can bias the machine learning model, even in simple ways like this, by just changing that, by giving it an imbalanced sort of set of training data. And by allowing students to play around with that, they start to sort of see how easily that can be done.
Yes. Thank you. Thank you for your answers. Yes, I think model bias is also a major fee for the machine learning engineers. So yes, that is why I'm curious and ask you about this question. Thank you for your answer.
Oh.
Yeah, one of our instructor was also saying this paper scissor thing is most biased project in our classes also. Yeah, Jamil, you want to say something? Yeah.
Yeah. So all kids try this project, and they can get right with the pictures. Like they show a rock gesture, and the model recognizes as a like paper or things like that. So yeah, it's been the most biased project so far.
Okay, so we have a question in the chat box. So it's like Jordan Wayne. So his question is, as a first learner of AI, where should I start from? So yeah. Okay.
Everyone learns differently. So as you can sort of tell from the examples I've shown, I learn by doing, by making. I can read page after page after page, and until I actually do it for myself, it doesn't sink in, it doesn't make sense. I learn by doing. I want to make something for myself, and by doing that, the penny will drop and something will click and I will understand it. But not everyone's like me. So, if that works for you, if you learn by doing, if you learn by making, then make something. There's, it doesn't have to be like the Scratch-based approach that I do. There's tons of amazing open source tech out there. TensorFlow is getting easier and easier to use all the time. Free to download. You can make something for yourself really quickly. There's tons of tutorials out there. But if you learn by reading, if you learn by watching videos, I would say there's so much amazing free content out there that I think that is freely available. I would work out what works for you in terms of learning it and go out and try it. But for me, it's always try it out, see what it does well, what it does badly, and go from there.
Yeah, right. So yeah, you got to identify where is the best, you can start with, identifying the way you learn things. Yeah, for example, like they mentioned, some of us it's good at start doing things and finding out. Then we see bigger problems, and also along the way we learn something. So from there we move forward and make progress. So things like that. So okay, so we have another questions from two guys. One is our student, I think. So the question is, what are challenges of machine learning? So it's more kind of generalized kind of questions.
So many.
Right.
The biggest challenge that I find is getting hold of enough data. Now, maybe that's a byproduct of the sorts of projects I work on. You know, if I was talking to you working at like a Google or a Facebook where I had access to massive amounts of data, then maybe I would give a different answer. But for me, I find that every project starts with, where are we going to get the data that we're going to use to train the computer from? Where are we going to get enough of it? Because that's really hard. And you see that every project faces this, and everyone tries to come up with creative ways of finding data that already exists or persuading people to make them training examples. You know, we've all done the prove you're a human by clicking on a photo that, you know, part of the photo has a car or a traffic sign or a street light or something. I mean, yes, to some extent you are verifying you're a human, but you're also helping train a machine learning model to recognize images relating to cars, which is, you know, we can guess, we can assume, we can predict that is possibly to help companies who are making devices like self-driving cars train their computer to be able to recognize that. So we try to come up with creative ways of getting the data we need, but that is often one of the biggest challenges. In terms of the challenge of applying it, I've sort of touched on that already, that how do we do it ethically, fairly, safely, responsibly? It's ethics in AI is perhaps the biggest challenge facing it, you know, making sure that we do this, that we apply this technology in a way that's appropriate and respectful. And we change, you know, like there are a lot of companies that only a couple of years ago were really investing in making face recognition technology. A lot of companies, we've now reconsidered whether or not that's appropriate. A lot of companies like mine no longer do face recognition because we have concerns about the ethics of doing that. So that challenge of not just what can we do, but what should we do, that's a consistent challenge of making sure that we get that right.
What are the weaknesses of AI and how the AI or machine will view human? Okay, then with some example, maybe it's like the Google case will be like a better example, maybe. Become conscious.
What are the weak points? Computers learn from patterns in the data we give it, and we assume that that's going to be the pattern we wanted it to learn. There are these stories all the time where a computer learned to recognize a pattern we didn't even realize was in the data. One that I've used a few times, I think it was Stanford, were doing a project around recognizing marks on skin of like whether or not a photo of a mark on a skin was cancer or not. So they collected two piles of photos, one pile of photos of normal skin, one pile of photos of tumors. But what they didn't realize initially was all of the photos of tumors, if you've seen medical photos, they always have a ruler in the photo for scale so that you can tell how big the mark is. So they had a pile of photos of a skin with a ruler and a pile of photos of just skin. So they trained a machine learning model to basically become a ruler detector. You would show it a skin with a ruler and it would say cancer. You would show it any type of skin at all with a mark and it would say safe. Now, to a human, that was obvious. It was obvious the ruler wasn't the important part, the relevant part. But to a computer, machines don't have the idea of, oh, well, it's obvious. They just went, the machine was trying to learn what all of those photos had in common and what those photos had in common. And the clearest thing that pile of photos had in common was they all had a ruler in there. So the weak points is that idea of just common sense of what was obvious. Of course, that wasn't what they wanted the machine to learn. Computers don't have that. They just learn from patterns in the data, and that often trips us up. We often don't realize that there was a pattern in that data we didn't intend the computer to learn from. And we're always trying to watch out for that and trying to prevent that.
We will let Day answer the last question. So then maybe we will call it a day. So yeah, so one question is can you please tell your point of view on the roles of AI in developing countries? So yeah, I think this is the good questions.
Interesting. I'm not sure I have a good answer there. Yeah, it's tricky. I mean, like I say, the technology is becoming more freely available. The tech is becoming more efficient, so it needs smaller and smaller computers now. You know, when I started, we would build racks of servers to do something that now can run in a web browser. So I hope that as the technology has progressed and moved forward, it's become more available to all. So it's not just the most developed nations who can afford massive amounts of computing resource, but it's now accessible to all. I don't know if that's true. I hope it's true. I hope it's now becoming something that everyone can start using. I mean, there are risks with that. You know, there are some benefits that in the past where it was only available to a select few, that it was hopefully being used appropriately, but now there are risks that as anyone can use it. But broadly, I see that as a positive. So I hope that it's now being something that anyone in the world is able to take advantage of.
Yeah, right. So I think another possible answer will be, I think using AI technologies, that can help developing countries, make progress, significantly faster. For example, like, helping them, in a way that, reducing costs, optimizing the resources, so that, it's help to make progress using, this incorporating AI. For example, like cleaning of wastage in the, the waterways, things like that, using AIs, so those kind of things. I think, yeah, I think there are many opportunities to embrace AI, in developing countries. So, but in the beginning, I mean, or first of all, we need expertise, who can apply, with the ground situation, with the knowledge on the ground, right? So then, that works. Yeah. So, okay, so that will be our answer, and also from Dave. Yeah. So with that, maybe I will conclude with one question from Dave for myself. So with regards to your book, so you give the title as Machine Learning for Kids. So why not like artificial intelligence for kids? So what is that, that differentiation between that names?
Yeah,
I think you have thought about it before giving.
Yeah, it's a good point, because I did sort of limit myself because initially I set out to explain machine learning, which is only one subset of, there are lots of other entirely legitimate ways of doing AI. So yeah, if I'd called it AI for kids, it would have, I guess, given me more flexibility to show even more structured and rules-based things. I'm not sure. I mean, actually, I've got to admit that, because it started, I did the website first, and then the book came out of that. And I've often regretted that, certainly the web address, because I do a lot of work with like 6-year-olds, 7-year-olds, and just typing that machinelearningforkids.co.uk is such a ridiculously long address that it can take them half the lesson to just do that. So if I had a chance to do it again, I probably would have come up with a different name and a much, much shorter name.
Sure.
So yeah, I don't know. I was setting out to do a very specific thing to explain machine learning, but yeah, it's totally, we should be explaining more than just machine learning. Machine learning is just one way of doing it, and actually AI for kids probably would have been a better, a broader thing to cover those sorts of ideas.
Okay, so with this, I think we like to thanks much to Dave for his kind of motivation talk, on AI to learn and to do something with the AI. So thank you very much. Thank you all our participants. Okay, so I think with this we will end today's talks, and thanks for Dave joining and doing this. And we wish you have a good day, and many good days ahead.
Thank you.
Okay, thank you.
Thank you, everyone.
Thank you, everyone. Thank you.
Thank you. Bye-bye.
Bye-bye.
Bye. Thank you, Mr. Bye.
Thank you.